Hi, it's Mrs. Lane, and I just wanted to talk about the real number system today. In Algebra 1, we only play with the real number system, although there are other number systems. We're just not going to use those right now. So when you do the real number system, there are a couple different categories. I'm going to do it this way first and then draw a quick Venn diagram to show you how they fit together. There are two main categories, the rational numbers and the irrational numbers. In rational, you can see the word ratio, and ratio actually means fraction. So rational numbers are numbers that can be written as a fraction. Okay, that's what rational numbers are. So if you think about the number 1/2, that's a fraction, therefore it's a rational number. The number 3 is also considered a rational number because you could write it as 3/1. You could also write it as 9/3. 9 divided by 3 equals 3. So that's also rational. You could have something like -2/7. Any of those numbers are rational numbers. If you're looking at a decimal, a rational number is a number that never repeats or that does repeat or end. So a decimal that repeats or ends, like 0.125 would be a rational number because you could look and see what would 0.125 be as a fraction. It would be 1/8. Because it can be written as a fraction, then it is a rational number. Okay, that's rational. Irrational numbers cannot be written as a fraction. They are decimals that never repeat or never end. An irrational number that may be familiar to you is pi. Pi is an irrational number because it never repeats and it never ends. The square root of a number like 2 or 7, those are irrational numbers because they never repeat and they never end. And if you look in Desmos, if I type the square root of 2, it gives me this decimal here, but I don't have the option to turn it into a fraction on this side because it is an irrational number, as opposed to, for example, the square root of 4, which is a whole 2. Okay? All right. So that's irrational numbers. And just in rational, you could put something like the square root of 4 because that's a rational number. Okay. Further broken down, rational numbers break into 3 groups. Integers. This is the word you'll see the most. You'll see integers, integral, like integral coefficients, things like that. Integers are positive and negative whole numbers. So if you go 0, 1, 2, 3, -1, -2, -3, and just keep going forever, those are integers. All right? Whole numbers are the integers, but starting at 0. So it doesn't include negatives. And natural numbers are the counting numbers, so they begin at 1. Okay, so now that you've seen the real number system, we're going to quickly draw a Venn diagram to kind of illustrate how it looks in that format. So most of the people draw, a box to represent numbers, and this is going to be the real number system. And then they have 2 non-intersecting circles. These do not intersect because rational numbers and irrational numbers do not intersect. There are no numbers that are rational and irrational. So the irrational numbers, again, pi, the square root of 11, things like that go in irrational. In rational numbers, then we have 3/8, we have negative, I don't know, 1/3. All of those kinds of numbers go under rational. And then as we get more specific, we have the integers. So you can see integers are part of rational numbers, but they're a little bit more specific. They are positive and negative whole numbers like that. All right, going in more specific, we have our whole numbers, which include 0 and then other counting numbers. And lastly, natural. Oops, can't really see it. Those are the natural numbers, and that is 1 and all the other numbers. So looking at this, if you look at the number 1, 1 fits all of these categories. It's natural, whole, and integer, and rational, and also real. It's a real number as well. Okay, but 3/8 here would be a rational number and a real number only. It doesn't fit into these more specific categories. Okay, I hope that brief video helped you understand what those things are, and have fun practicing. See ya.